Okay, so to get the equation of the quadratic, we estimate, we use transformations. That's the answer I got from the class, okay? Everybody nodded their head, said, yeah, let's use transformations, okay? So I'm happy with that. And the vertical and horizontal shifts. Yeah, that was mentioned. That's the first thing you want to do, okay? Yeah, you could do the vertical stretch, but that's a little tougher, so we might not even really do that, but I'm going to show you how. Okay, so let's find the coordinates of the vertex. Let's do that. And okay, I think the vertex is right here.
And then the transformations are the B and C.
Okay, so my estimate of the vertex
So A is the stretch, B is the...
is 3.2, 1.7. Okay? Now the vertex, you know, when you start with the y equals x squared graph, of course the vertex is at the origin. When you vertically stretch it, the vertex is still at the origin. So whatever you did to the vertical, for a vertical stretch, it doesn't affect the fact that before you do your horizontal vertical shift, the vertex is at the origin, which means that the horizontal shift is 3.2 and the vertical shift is 1.7. So in vertex form, right there is the equation of your quadratic, right? So that's really easy. Now you still got to find A, but we've been doing that for a couple of months. Okay? So how are you going to find A? Now that is your vertical stretch, right?
Yeah.
Okay, so we could say, okay, well, A is your vertical stretch. So if you move over 1 unit here, how far do you move up? If I move over 1 unit, I move up this far. How far is that? Well, that's this far, which is about, on this scale, about 1.5. Which means that before we shifted this graph, the vertex was at 0, 0. And if you went over 1 unit, you had to go up 1.5 units, right? Now the original graph had the point 1, 1. In order to get the point 1, 1.5, which would have to be in this graph according to this part of the picture, okay? I'd have to multiply it by 1.5. So right there is my vertical stretch.
Geometrically vertical stretch. Geometrically.
So that would be your value of A. That would be your function. Okay? Now I didn't do a real good job of sketching this thing, but let's now use a different way to get A. How else could we get A?
Plug in y and x.
Plug in an X and a Y coordinate, right?
Yeah.
X and a Y coordinate on this graph. Now we can't use the vertex, and we just did this last week. We can't use the vertex, but we could use any other point on the graph, right? So we got a horizontal line through 7.7. No, it's not through 7.7. It's through x equals 5, right? So we've got a point over here and a point over here whose y coordinate is 5. That's handy. We can use that, right? Now if we want to use another point, we can, but since we already have this horizontal line where y equals 5, and let's just kind of extend that line. That is a line y equals 5. What do you estimate the x-coordinate is here?
4.6.
Looks like 1, 2, 3, 4.7. What?
I said 4.6.
That'll teach you.
4.7.
It's clearly 4.7. Let's make, I'll use 4.6
No.
just so
use
you can
4.7
feel
now.
victorious,
So,
okay?
It's fine.
And it isn't a competition. Just so you can feel good about your estimate. That's what we're going to use, okay? It's going to give us terrible results because it really is 4.7. We're going to use it.
Please do it.
We're not going to get good results anyway, okay? The equation we get will not have vertical stretch of 1.5 when we use this point, okay? I don't think. If it does, I'll be pretty surprised. But it's probably not going to be that far off either. Okay, if I drew a good parabola, and if I drew a bad parabola, which is entirely
Why are you
probable,
saying if?
and the graph isn't that great anyway, you know, who knows what we're going to get. Okay, so anyhow, here's a point.
Do you have a frequency
Let's
calculator?
switch colors here. So I'm going to say, okay, we got a point
Are you gonna work?
4.65 on the graph of the parabola. Incidentally, this is okay, and that's this point down here. Okay, so from this, we know that y is a times x minus 3.2 squared plus 1.7, right? And now we have the point 4.65, x is 4.6, y is 5, so we have 5 equals a times 4.6 minus 3.2 squared plus 1.7, right? So 5 equals a times. Now that's 1.4. 1.4 squared is 1.96. And I'm not going through the details of solving this linear equation. Subtract the 1.7 and we get (1.96a) equals 3.4, right? Now you can check the arithmetic on this. And naturally, because we use Candace's point instead of mine, this is not going to come out very good.
Mine's the best.
Okay, well, yeah, it's going to come out just fine. Okay, comes out closer to 1.5 if you use 4.7. I'll let it ride. Okay, so we get a equals 3.4 over 1.96 comes out 1.7. Okay? Now, that compares pretty well with the 1.5. It's not bad at all, right?
Not bad at all.
So your y is approximately 1.7 times x minus 3.2 squared plus 1.7. There are too many 1.7s in this, but it's not my fault. Okay. Right?
Right.
That's what we get. Okay, now I get 1.7 here because 1.96 is close to 2, so we're only off by 4%. And 4% of 1.7 is actually close to 0.1. So maybe that should actually be 1.8, but I don't want it to be that far from this.
Maybe if you did
So I'm gonna fudge it.
4.7, it would have came to 1.8.
Okay? So you can fix the arithmetic if you like. It's not all correct, but it's all pretty close. Now the point of all this is that if I give you two graphs of quadratic and or linear functions, And a scale, you can figure out equations that pretty well match those graphs, right? They can be a little off. That's okay. I want to see a good estimate. Okay? But that's something I'll expect to be able to do. Okay? Now, there'll be easier problems where I don't expect to do anything that hard. But half the tests will be problems where I expect to be able to do such things, so we've done a lot of this. Okay? It pulls things together. This pulls it together all kinds of stuff that we've been doing all semester. Okay, well, now, while I walk all the way over to the camera to turn it off, okay? It's going to take me a while. Yeah, I'm moving slow today.
Me too.
Actually, I'm moving quicker than usual today, but that's just a coincidence. Now, I want you to estimate the points where the graphs intersect.